Um, YouTube stream? Since you're already logged in, you'll do your 3 hours. Oh no, Joseph. Godspeed. Good luck. I always see there's a question from chat. I never did get around to doing Penn-Center's complex variables final. So this might be the downtime thing that we do for now. Using the limit definition of a complex derivative, choosing delta z equals x. Oh crap, how does this work? Um, yeah, we can split it up into I want to look back and see if I can dig up the definition of a complex derivative to make sure that I'm on the right track here, but we take z equals to x plus iy. Um, and we can do like a multivariable limit. But I want to look up what this delta x thing is again. Just to make sure I'm not... I can probably figure it out if I just think about it, to be honest. Like, I can probably figure out what it should be. So I just realized I have an idea in my head now, but... I'm already looking at this. Let me see if I can just find it. You know, I probably need to look at the actual worksheet, don't I? That might be my issue. Let's bring up week 3, class 2. This is a little bit ahead. I'll bring this PDF up because we'll probably need it. Hey, Waffle! Is that the command from Penn Center's thing for the eat? I can't do it with my voice, like the Metal Gear Solid. Oh, I found the thing that I need. Or maybe just doing the double exclam for fun. I said that Penn Center as like a command thing that like will play a sound. Just where my mind went. Either way though, hey. Okay, this is the definition of a complex derivative, and we're being given 2 different values to try for delta z. So I guess we don't need to do... We might need to do z equals x plus iy. We definitely need to do that still. Oh yeah, absolutely, Waffle. If you have a question, this is just like a filler. Let me back out. And while we see what your question is, I'll just kind of take a look at what the rest of this final has in store. Proving out someone to look at it feels wrong. That the thing proved is true. Okay. Determine where it's differential in the complex plane. Determine where it's analytic in the complex plane. I'm having to figure out analyticity. Isn't it just... Doesn't analytic means that the derivative exists? It might actually be in this thing here. Oh, did you post it? Let's see. You read this in programming class. All right. Oh my god. What kind of bee makes milk boobies? Oh my god, that works on multiple levels because that was a freaking jump scare, and there's the word boo involved. Oh my god, I even saw the thing pop up in my activity feed, but I still got jump scared. I saw like something popped up. I didn't expect that alert though. But yeah, this track down here was making me laugh at first. Even using 69 cheer. Oh, true. Okay, so is this gonna be equal to 100? Take a value 99.9 repeating, by definition this continues on forever. Note the 99 part couldn't be any positive integer so long as the 100. Oh, okay, yeah. Like the 99 isn't the important bit. The 0.9 repeating is the important bit. So it has to be a number 0 point infinitely many zeros and then a 1. This number has a 0 digit which continues on forever. Okay, yeah, I was about to say that I feel like the existence of a number like this is debatable. Ignore how you've written like 3 proofs in your life. I'm basically the same. I'm not a fan of writing proofs. I try to avoid it. The one also implies that the number terminates. By contradiction. Okay, yeah. Seems fair enough for these two sentences. Let's take the value, 99.9 repeating and say x is equal to the difference. X cannot equal 0 since those two numbers aren't equal, but by lemma 1, it also can't be infinitely many zeros and then a 1. By these conditions, x can be best defined as a positive number that is infinitely small. This proves an infinitely small positive number cannot exist. Oh gosh, I remember that, like, this idea being like a meme in the math community like a couple months ago, and I never really looked into it. Look at it. It feels wrong. The thing proved is true. Yeah. So this makes me. I guess we're not actually stating that 99.9 repeating equals 100 in this proof, which is nice not to deal with that particular issue. So I think maybe the weird thing here is that we can always imagine a number like what this idea is expressing, where if we have 0.01, we can also write 0.001, 0.0001, and we can always put in as many zeros as we want. I think the issue is with this exact definition of this very small number of having an infinity amount of zeros and then suddenly sticking a 1 onto the end of that infinitely long thing. That just... it's like if you imagine like a line of people at the DMV or something that's infinitely long, you can't just get to the end of that infinitely long line and put yourself in line after that. That's basically what that one is trying to do. So that, like, the idea that you could always stick another 0 inside of here is correct, but once things get to like literally infinity, it doesn't quite work like that. That's my kind of interpretation of why you get this weird result. You can still make a number that is super, super small, but it's just you can't really define it in this exact way. But yeah, this type of idea has always been super weird to me. Yeah, I'm trying to think of a good, like, a good way of expressing this. If we have 1 over 10 to the x, just like an exponential function, y equals that. Like this thing here is going to be, you know, if x equals 1, we get 0.1. If x equals 2, we get 0.01. If x equals 3, we get 0.001. So this is like the fractional version of this idea of always sticking a 0 inside of there. And so when you take a calculus class, you'll learn that if you let x get infinitely big here, you just get 0. You don't get some positive, very small number. Like the curve of this thing is very quickly dropping off towards 0, not towards 0.001. You basically say, like, in the long run, it's going to basically be 0, I guess. I'm saying the word basically a lot for something that isn't basic. Yeah, that's my interpretation of what's happening here. I guess there's also a separate idea that I could relate this to, which is if you're talking about integers, you can define what the next integer after another one is. If you take 1, you know the next integer is 2, the next integer after that is 3, the next integer after that is 4. But you can't do the same thing with real numbers. Like there is no real number after 1. Because you, like, you know, you could always say 1.0001, but then the next person you say, oh, well, what about 1.0, and then they put another 0. Yeah, I don't. It's kind of it's a weird thing with math. What else confused me was that it's like technically always going to be a little bit off, like how the rounding is geometric series works, but it's not truly equal to 0, the sum of an infinite geometric series. Yeah, right. It's gonna be like getting very close to 0, or maybe like even going up and down, above and below 0 and going towards it, but you don't actually have 0 until you get to infinity. And that's the difference between taking a very big but finite number of terms and literally infinitely many terms. So weird things happen when you involve infinity. Maybe it's the moral of the story. Numbers are quite weird. Yeah. New conclusion, true. Yeah, I mean, we talked about in the last day of Zach's real analysis class, but you can prove that there's more numbers between 0 and 1, so all those like decimals, there's more, the set of that numbers is bigger than the set of all integers. They're both infinite, but one is still bigger than the other. And that's actually somewhat related to like the problem here. But yeah, there's weird things when you get into sets of numbers like that. Yeah, exactly. And so these real numbers are kind of like the next level, like the bigger infinity, and that's why you get this weird result, I think. Math channel, my teacher assigned the proof of the Riemann hypothesis as my homework. Help. I mean, why would I help you win $1 million, you know? I mean, I think your teacher just wants $1 million, to be honest. That concept is really interesting, yeah. Sounds like a teacher. How big is your infinity? The whole week? Nice, nice. That would be a good mug, too. Only bug is a Klein bottle? True. So yeah, I hope that helps, Waffle. It's definitely a weird thing. Klein bottle is a bottle with no inside or outside, I think. It's like a mathematical like object that someone came up with. So because of the way it's made, there's like the outside surface is the same as the inside surface. This maybe isn't the best. There should be a Wikipedia page on this, right? A non-orientable surface that is an informally one-sided surface, which, if traveled upon, could be followed back to the point of origin while flipping the traveler upside down. So yeah, there's only it's like a three-dimensional surface, but it only has like one actual surface because of how it goes like back inside of itself. What is like a good Mobius strip? Penn Center gave like an actual Klein bottle object away for his QED giveaway too. See if I can find it in his Discord. I forget who won it. Fine. Ah, man. I can't easily find it, so I'm not gonna try. Hey, Phobos. Thank you, thank you. All right, so yeah, if there's anything else from you, Waffle, let me know, or if anyone in chat has something, can let me know. If not, I'm gonna go back to this complex variables stew. It's not easy, so I'm not exactly Phobos. Why would I do something that's difficult when I can also do something that's easy? Sounds good. So yeah, this is Penn Center's complex variables final exam. Just figured to make a good filler for today. There's only 4 questions total, thankfully. And so I just pulled up the limit definition of a complex derivative, which is here. Just like a normal derivative, but you have z's instead. Okay. So the function in question is f of z equals z conjugate, and I assume I could equivalently write this as f of x y equals x minus iy. Now the limit definition of a derivative for a complex function is f of z naught plus delta z plus f of z naught. Is it minus? I need to look at that. It's probably a minus. It's almost certainly a minus. Because that's the formula for slope. It is a minus. And so for the first part of part A, we need to take delta z equal to x. And we are supposed to get 1, which that's nice of Penn Center to give us the expected result. Why is delta z equal to x? That notation actually a little bit confuses me now that I actually think about it. I see that it's like we're approaching along the x direction, like along the real axis, the positive real axis. If z naught is x plus iy, then delta z, we're saying is x. Like, is that what we do? Let's see if it gets the right answer. That'll be 2x minus iy, question mark? So the iy's cancel. And we get, I think we get the correct result here. Because 2x minus x is 1x, divided by x is 1. Heck yeah, you know, one new notation on the board. Oh wait, if it wasn't the delta that you know, do you know the limit? All a delta means is change. So delta z, ooh. All right, well, delta is being used in a little bit of a different. Delta z means some very small change in z. It's just a very small number. It's not infinitely small, you know, 0.0. No, it is. It's a number that's getting infinitely small. Which is, in this context, not quite as clean what delta z means. So like, I'm maybe to use a different example where in physics, you often have like a delta time or delta t, and that's your t final minus t initial, just like for some time interval is what that like delta t represents. You might as well have like delta x for a change in position. That delta z, it's like, it represents the same idea as what's happening here, but it's using it in a little bit of a different sense. Limit notation is what we did in class today? Oh, cool. Then write false to answer the problem? Saying, like, I mean, usually the limit is false. You can like if you got the wrong answer at the end here, you could say that you made a false statement. Like if I randomly got 0 here, I would say false to 0 being equal to that. That's weird though. I don't quite know what false is doing in that. So there's a part 2 to A where we take delta z equal to IY. Okay, so what's happening here? X minus 2IY after we conjugate minus X minus IY over Y. The X's cancel. We have minus 2Y plus IY to get minus IY over Y. That's not good. Or just get -1. Just ignore my brain died. No worries. We're supposed to get -1, not. Oh, I didn't sub it right. Delta Z, we get IY. There we go. -1. All right. I don't know if my work is perfect here, but I want to call part A done. Verify your findings from parts A and B. Well, this is part B. Oh, maybe this used to be part A was delta Z equals X, and then part B was delta Z equal IY, and then this was part C, but then it got combined. That's my bet. Hey, CW over on YouTube. You're in the process of getting into the Putnam exam. Any suggestions for prep? Nothing besides the obvious. I guess I never have tried to do Putnam anything, so yeah. I'm sorry. I don't have a lot of advice there. To be honest, I'm not a huge fan of doing that that type of math, so I haven't really tried to study for it. But yeah, like the only advice that I would have is like the obvious things, like going back through the past exams and stuff like that. But I'm sure you already know that. What are the Kwashi? Oh, sorry, the Kwashi. Putnam, as far as I know, it's like it's a math competition that's been around for a decent amount of time, I think. See if I can find it. Yeah, it is, Jed. And I just like making fun of that. The preeminent mathematics competition for undergraduate college students in the United States and Canada. Yeah, it's just a another math competition. Yeah. Yeah, I'm sure Penn Center is, you know, who charged a fortune for these PDFs is gonna charge for edition 2 next year. Yeah, I remember someone giving me a Putnam question at some point. Yeah, they are not easy. It's like this is the last year's one. Which one did I try? It might have been this one. Oh, the weird notation. Oh my god. You know, I thought I'd be able to pick out which one you're saying has the weird notation, but these all have some interesting stuff going on. Oh wait, no, it was this one that I tried, I think. Was it? No, I don't remember. Everything, yeah. So they use some calculus ideas here. It's like f double prime. Should I assume it's what puts it in the college realm? A6? It might have been that one. This one feels like a Project Euler problem. That one with taking the stones with that game. I think that was a different set of rules, though. Hey, Takshio over on YouTube. Find A if the equation 1 minus cosine of x is equal to... Are those brackets... what function do those brackets represent? Like greatest integer function? The square root of 3 times the absolute value of x over 2 plus a. Right, yeah, the vertical bars for being mod x is fine. But what's around the square root 3 mod x? Oh, those are just brackets? Okay, okay. I guess let's think about it. Let me get the problem on screen. 1 second. Okay, so do you think you could show your approach then also show the graphical method? Yeah, I'm not sure what my approach is going to be yet. The graphical method we can certainly do, but let's see if we can figure it out with algebra first. I mean, honestly, I'm probably going to draw a rough graph of this thing anyway. Plus A. Oh, is the plus? Did I write the problem down correctly? Does the plus A go on the right, like how I wrote it? And x is on 0 to pi, not inclusive. I was about to spell out pi. It's like, does the A go here or does the A go down here? I got it right? Okay, good. Thank you for confirming. I was thinking of doing something like isolating A on one side, bringing all the other terms to the other side, and assuming A is f of x. Maybe there's something in there too. I don't quite understand how you would go from there. If you want to do something like that, my instinct would be to subtract everything over, letting equal 0, and like treating the entire thing as a function and finding where it's equal to 0. That I know that could work, but I kind of want to draw a rough graph of these because it seems like the thing that we're allowed to control here is A, so it's basically gonna come out to vertically translating this absolute value function up or down to make it have a single solution. So 1 minus cosine of x, that means we're taking normal cosine of x, translating it up by 1, and the negative in front means that it's vertically flipped. So if normal cosine of x is like this on 0 pi, we're shifting it up by 1 and then flipping it vertically. So I think it's going to look something like that. Oh, sorry. It's going to go as high as 2. And then to the right as far as pi. You want to consider A as a function in x, then for what interval would the graph give you only one solution? I mean, if A is a function of x, though, I feel like you would get a lot of different solutions. So that's why I'm not quite sure what's happening with that. So that's the cosine function that I graphed. Kind of funny, we're given the absolute value of x, but x is always positive, so it's not really affecting much here. It's just going to be a line. When x equals 2, so like on, when x equals pi, ooh. When x equals pi, we get root 3 times pi over 2. Root 3 over 2 is less than 1, so we get something, oh, god damn it, comparing it to 2. Okay, well, anyway, I assume the issue is that we're going to You know, maybe the graph isn't all that helpful here. Like, I think doing this by hand is actually not all that helpful, now that I actually try to graph this thing. What do we do, though? Like, so, like, this thing on the right, it's going to end up being a line, something like that. And so I assume it's going to be, like, it's going to hit the cosine function in two places, and that's the issue that we need to avoid. I'm trying to figure out if we want to translate up, just skim along the edge and be tangent, which actually, that's probably a good strategy. Or if we want to shift down and like go below it. So actually, I now that I said the word tangent, I think we can maybe use some calculus here. We want to figure out what point along this curve is the tangent line having slope √3/2. So if we let f of x equals 1 minus cosine x, f prime is positive sine of x. And we want to know, when does sine of x equal √3/2, because that's √3/2, which is like the slope of the line. X between 0 and pi. So this is just, you know, we can just solve this here, take the arc sine of each side. This is interesting because there's actually two solutions. Well, sine of x is √3/2 at pi/3. And also at, it should be 2 pi/3. Let me look up the unit circle, but I think it's 2 pi/3. Is 2 pi/3 outside the interval though? No, it's not. Yes. It is 2 pi/3. Okay. How do we know which one we want? Maybe it doesn't matter. Maybe they both work. I want to figure out, I'm a little bit worried that with x equals pi/3, there's the off chance it'll hit the function some second time. I'm not really sure though. This one, I think we need to look at the graph of this to really be sure of this. But I think like once we know this, these functions should be equal to each other. We want them to be equal to each other at x equals pi/3 or x equals 2 pi/3. I think I might just choose 2 pi/3 because it's just what my gut is telling me. I don't have a very good like I guess I feel more secure being later on in the interval here because I'm imagining a tangent line like this, I can very easily visualize is never going to intersect a second time. Whereas a tangent line down here, it might hit it a second time somewhere, but that might just be my own inaccurate drawing. But we know these two things should be equal at one of these things, so I'm going to choose 2 pi over 3 for the reason that I said. And we can just see what A has to be to make them intersect. 1 minus cosine 2 pi over 3, oops, equals root 3 over 2 times 2 pi over 3 plus A. Now just solve this for A. Cosine of 2 pi over 3 negative a half. Does that make sense? I think so. Absolute value of 2 pi over 3 is still 2 pi over 3. We get root 3 over 3 pi plus A. So if I did my math right, it's 3 over 2 minus root 3 over 3 times pi. I'm not all that confident though. I don't think we need it, Fembox. I'm not sure why it's there, to be honest. Let's go to the graph though, because this actually requires a little bit of exact graphing if we want to do it graphically. Like better than I can draw at least. How do you do an interval? Restriction is a better word. Okay, curly braces. 0 less than, x less than pi. Y equals square root 3 over 2. The absolute value of x plus A. Same restriction. So if A equals 2 pi over 3, I am wrong. I got the wrong answer. Sorry, no. I didn't plug the right. 3 over 2 minus square root 3 over 3 pi. Oh no! Wait, but if we do the other solution, there's no way, right? The other solution should be 1/2. No? The other solution should be a 2 on the bottom. It should be root 3 over 6. Wait, this problem isn't possible. Or maybe it is. It is possible, just not with my technique. Oh my god. Hey, Sahil, I'll take a look at that problem after this. Oh, wait. This does help. There's many solutions, though. So, okay, what I've done, I think, is I figured out the intervals of A that don't work. Yes, Pakshiel. Exactly that. I found anything between Um, how can I show this? Pi. Okay. So anything between the blue and purple lines here do not work. So we can choose any A that is less than this small amount or greater than this big amount. And I think they should all be solutions here. That's really hard to understand without the graph, though. I don't know that I would have gotten that. Gloverman, thank you for the follow. So yeah, talk shit. I guess from here, you can kind of choose whatever value of A is your favorite that fits these constraints. It's like, we could be really complete and say that A belongs to 0, comma, the smaller value, which was 1/2 minus root 3 over 6 pi, union the bigger value, which I wrote right there, 3 over 2 minus root 3 over 3 pi, oops, comma pi. Any value in those intervals should work. You got an idea now? It does look difficult without seeing the actual graph. Yeah. Any other approach that comes to mind? Yeah, I'll explain again first. So what I did is I noticed on the right we have a linear function. And what this A allows us to do is shift a line of a given slope, root 3 over 2, up or down vertically. So we can define like what vertical displacement we actually want. And something that is relatively easy to find are tangent lines because we know calculus. So I found the derivative of the left-hand side, 1 minus cosine x becomes sine of x. And then because this is the slope of the tangent line, sine of x, I equated it to the slope of the linear function on the right-hand side, root 3 over 2. So I solved this equation for x, where x is between 0 and pi. There's two solutions here, pi over 3 and 2 pi over 3. And so given these are the x values that we want, we can plug them into our original equation and figure out what A must be for these two sides to be equal. So I worked it out by hand for 2 pi over 3. And as it turns out, we want values that are outside of these two bounds, not in between. And that's the part where I don't know how you work it out without a graph. Deciding if you want to go between or outside. Cleverman, you have a simpler question relating to unit fraction, exponents, and base. College Algebra 103 whenever you get a chance. Yeah, feel free to put it there in chat or in my Discord. whatever's easier for you. Without a calculator, what you'd have to do is take the value of a that we found, plug it in up here, and somehow solve it for x. But that's not when you have a cosine and just a regular x, you can't really solve it. That's the problem. That's why I'm struggling to come up with a technique that would actually work here. Like, I don't know how you can verify by hand this thing. That's where I'm struggling with your question there. Hey Ben. Math question for you. For all y there exists an x such that y equals 0 or xy is greater than 0. It could be written instead of using the or sign. Could you use the implication here? Oh gosh, I'd have to look that up. Let me look at yeah, if you want to DM like the LaTeX version, sure. Let me look at Gloverman's first. All right, no worries, Takshio. And Sahil, I haven't forgotten about you if you're still here, but that problem's going to take me a while. So I'm doing some shorter ones first. Shibu asks, if a person knows pure maths, how much can it help in statistics like random variables? It can help, for sure. Statistics gets pretty, like, depending on what angle you take for stats, it can be pretty pure as well, to my knowledge. It's good to know. So you have minus 343 to the power of 1/3. Let me just spray this thing. I think I mentally figured out what the answer to this is, but mental math is not my strong suit. So minus 343 to the 1/3, and you need to figure out, like, how do we deal with an exponent like this? So if you have a fractional exponent, you can always think about it as something similar to a square root, because if you say had 64 to the power of 1/2, we could also rewrite that as the square root of 64. Like the square root and the exponent of 1/2 are the exact same thing. And you don't have to do this, but this is often more familiar to students, which is why I'm saying it. And the square root of 64 is really asking what number multiplied by itself gives you 64. In which case, you're just gonna have to know the answer is 8, or you have to do some trial and error. Similarly, up here, we have a 1/3. The negative sign, it's a little bit, I'll input it inside. But because it's a 1/3, like we had a 1/2 down here, but when it's a 1/3, we get a cube root. And this question is asking what number multiplied with itself 3 times gives you negative 343. There's a little kind of trick here where if you, the negative sign is weird. With a cube root, it's actually fine. With a square root, negative signs are not okay. But a cube root, it actually is fine. Because a cube root is what number multiplied itself 3 times gives you the number underneath the radical. So if you have, like, say, negative 2 cubed, you get negative 2 times negative 2 times negative 2. Well, that's positive 4. Positive 4 times negative 2 is negative 8. So when cubes are involved, negatives are perfectly fine. Squares, it's not fine, but just a little like a digression, I guess. So the problem that we have here is what number multiplied 3 times gives you 343? And there isn't a better way to do this outside of either using a calculator or guessing and checking. You can do an educated guess and check here, but it comes down to guessing and checking. And 343, oh, okay. I think the answer is 11, negative 11. Because I'm just kind of seeing that like it starts and ends with a 3, which is kind of weird, and 11 is kind of a weird number, which is what made me think of it. So let's actually try, what? It's not 11? It's 7? Ah, okay. I thought I did the mental math right in my head. Evidently I didn't. Oh, you're right. 11 cubed should be over 1,000. Okay. Well, the answer is 7. But what we do is we take our guess and we try cubing it like I did up here with the 2 and see if we get the negative 343. So my guess is negative 7. So let's cube it to get negative 7 times negative 7 times negative 7. So negative 7 times negative 7 is positive 49. So times negative 7. That, I mean, I'll just even do it by hand here. If you have to use a calculator, just do that, but I'll do it by hand. 63, so 3 carry the 6. 28 plus 6 is 34. Perfect. And that was a negative 7, so it's negative 343. So because we did this work, we can claim that the cube root of 343 is negative 7. So I hope that helps, Cleverman. There's another type of problem that they could throw at you, which is they could throw at you negative 343 to the power of 2/3, where you can still work with that. Basically, and sorry if you don't have to like know this, but I'm just trying to prepare you for what's usually the next step with these types of problems. So over here we had a 1/3, now we have a 2/3. Well, so what we can do is we can use exponent rules to make this a simpler problem. So I'm going to rewrite this as negative 343 to the power of 1/3 squared. Because an exponent with an exponent like that, the exponents will multiply. So 1/3 times 2 is 2/3. So this is still like, this equality is valid. These two things are equal because 2 times 1/3 is 2/3. And now inside the parentheses, we have the exact same problem we had up here, so we know it's negative 7. So we get negative 7, and the squared is still out here. So then you square it, and you get positive 49. You could have also done the reverse, if you're feeling like a masochist, I guess. You could also equally as validly have written minus 343, oops. Ugh. Squared to the 1/3, but you don't want to have to square this number and take the cube root. That's going to be a ton of math. So this direction is a lot easier. And actually, I should have, the negative sign is a little bit like finicky. I was being a little bit fast and loose with the negative sign, but it's technically this. Because like I said before, negative signs with fractional exponents are a little bit weird. Change the exponent to 1/5, find a number that equals a number to the 5th power. Exactly that, clever man. Yeah. That's the pattern that you need there. No worries. If you ever think you're getting math help in the future, let me link to a bunch of people who do math help as well, in case I'm not around. Everyone in that list has math help of some kind. If you look at the math category on Twitch, you might just happen to find someone who's streaming there, but I'm not the only one out there who does math help, so whenever I see a new face, I like to kind of give a shout out there. And hey, Kareem El Asri over on YouTube. I'm not too good at those types of questions, and I have a couple other questions. I guess I have one other question I need to get to first. I'm not quite sure the answer to yours is, but I'm not too good with functional equations like that. Oh wow, it's a kind offer, Waffle. Yeah, you're right, Bluebird. It's more proper to put the to include the negative inside the parentheses, because it does change the value of the problem. Actually, in the first one, it doesn't matter, but in the 2/3 one, it does matter, as Bluebird points out. How would that change value? That's a good question. So all the math that I did here was including the negative sign inside the parentheses. The important thing that happens here is that we end up at the end here with -7 squared. And a negative squared always turns into a positive because -7 times -7 is positive. If we instead had the negative sign on the outside, so I'll just repeat my work here. But with the negative sign on the outside. So now that the negative stays on the outside, now we get 7 squared with a negative sign in front. So we end up with a -49. In the first version, the negative sign also gets squared and goes away to become positive. In this second version, the negative sign stays on the outside and never gets squared. So we end up with a negative answer. That's the important difference there. Yeah. Okay, so the question that Ben asked, basically we need to convert this OR into an implication. And I'm pretty rusty on my logic. Like we need to make an equivalent statement that uses an implication here rather than OR, I guess. So what is this called again? Like I've done problems like these before, but not for a long time. When I took my discrete math class in college, basically. To implication. Let's see if this gets me what I want. This has ands. Oh. Well, this seems like the answer here. S or T is equivalent to not S or T. And I guess not something or something is equivalent to if not something, then something. I would need to actually write up the truth table to see that for myself, but I think the answer is going to be if not y equals 0, then xy is greater than 0. Yeah, this is maybe a... This like states the actual property that we're using here a little more explicitly. Not P or Q is the same thing as if P then Q. And so we don't have a not in here though, so we can force it to be here by putting two nots. So saying this like not y equals 0 or xy is greater than 0. Let me just write it out. For all y, there exists an x such that y equals 0 or xy is greater than 0. Mangoes! Tearing up to Ghoul since you... Yeah, I haven't done this stuff in so long. What they're saying to do here is okay, let me, before I even get into this, we want to use the property. Ugh. Come on. Not P or Q, if and only if P then Q. Like these two statements are the same thing. We have the or, but we don't have the not, so we need to force a not to be there somewhere. And so what they're saying to do is to take this y equals 0 and double negate it. So not y equals 0 or xy greater than 0. There's probably a better way to represent it. Like maybe not and then make that a not equals or something. And so now this chunk is P, the not from the outside is still there, and this chunk is Q. So with this like scheme, I guess, whatever, we can apply this property here. So for all y, there exists an x such that not y equals 0, or if not y equals 0, then xy is greater than 0, and I'll probably convert this into y not equal 0. I don't know if you should do that off the bat or not. For all y, there exists an x such that if y is not 0, yeah, okay, so as long as y isn't 0, you can always name an x that makes the product greater than 0. So intuitively, this statement still makes sense to me. Are you just negating the negation? Exactly. We don't want to change. We don't want to change anything. Which is exactly how I would have before I dropped out of grad school. Oh, nice. I'm just kind of making it as I go, to be honest, but I appreciate it. So like, oh, wait, what did I just hit? I don't know what key I hit, but oh well. We don't want to change anything. These need to all be equivalent statements here. So these are all double implications. Like, we do the double negation, so we haven't actually changed the value of the first line. What if y is 0? Yeah, I was kind of wondering that in my head too. These little p and q. Oh yeah, I did that for my own like benefit, to be honest, because I was getting confused which not to use. So I think this is still okay because of if-thens being vacuously true. I want to say if we do this truth table, if your original condition isn't met, like if P is false but Q is true, it's vacuously true. There's some weird thing with implications. I should probably actually just Google it. But you're right. I haven't. That's why I think this is okay. But you're right. It doesn't seem to be addressing y equals 0. It's not in the same way. I think it's implicitly still doing that. Implication vacuously true. If P is false, the statement is true regardless of the value of Q. And I think it's true because it's just the statement isn't wrong. It's not necessarily right, but it's just not wrong. I guess that doesn't really address your question, because that means we're not addressing y does equal 0. We change the equation from an or to one where we disregard the base case where it isn't true. I feel pretty confident that this is right. I'm trying to figure out the logical explanation for why, though. Oh, okay, nice. Yeah, that's probably it, mangoes. Um, it doesn't say anything about the product when y does equal 0. That's probably how we explain that. Yeah, because in both situations, we're figuring out whether y equals 0. Like, I guess maybe this first one says if y does equal 0, then we can already stop this statement is true because it's an or. We don't need to bother with the right-hand side because we know that y equals 0. And here, I think it's the same thing, where if y does equal 0, then we can also stop, like there's nothing else to say. Whereas if y doesn't equal 0 in either case, we proceed to the right-hand side. It's definitely a weird thing, though. Like, when I first wrote that, I felt a little bit uncomfortable with it, too. But yeah, Mangoes, I like how you're explaining it. My brain is confusion. I keep doing the wrong hockey. So, in both the top and bottom statements, an interesting thing only happens when y is not 0. So, like, the interesting thing in the first line is that when y isn't 0, we can name an x such that xy is greater than 0. And the same thing is true with the last line. That something interesting only happens when y is not 0. Like, in the first line still isn't saying all that much about y being equal to 0. Like, it's not saying anything significant. It just says that y must be 0. But you're not saying anything else about y after that. And the same thing is true with the fourth line. I bet we could write out a truth table for this case. Well, like, a truth table would be a little bit weird, but like, it's actually probably a misuse of truth tables. But I'm imagining that you could do a truth table like this. guess we really want... We need a good couple of columns here. Like, I think you could do some kind of truth table like this, and you should get equivalent statements here. Already the weird thing is that these things can't both be true at the same time. So when we come over here, I don't know what to write in that row, so that one's an oddball that makes me think that there's something invalid about what I've done here, but otherwise we get true, true, false. And then if we compare these two and with an implication, these two should be true, true then true is true, true then false is false. I assume that should be a true there, because it's an or, but I don't know, maybe that's not the most helpful thing to actually do, but hey, Holonomi, my tags. Does your about really mean to say there's no problem you can solve? Yeah, it used to say there's no problem I can't not solve, but everyone kept reading it like there's no problem I can't solve, and then they Google a really hard problem and ask me that. So I changed it to no problem you can solve, and hopefully people don't overlook the double negative. Well, I guess I took out the double negative because people kept misreading it. This thing is a problem, only opportunities. There you go, Ben. Yeah, Jed, it should be true generally because an or is true in that case. We just can't have that y equals 0 and xy greater than 0. That's why I'm getting a little confused on with this approach, but in general it should be true for an or. This is just a little bit weird. And hey, Stooky. Are we trying to logically prove that statement? So basically the task that Ben gave us was take this statement, convert this or into an implication. And so I think we successfully did that. But what we're trying to, there's a little like detail in what we did that we're trying to explain well. I think Mango's figured it out, but what the issue that Ben is pointing out is that, yeah, exactly. The first line addresses y equals 0. The fourth line does not seem to address y equals 0. But I think Mango's explained. I mean, I guess the first line isn't really addressing y equals 0 either. It's just saying it must be 0 or the actual interesting thing. We're still not saying anything that interesting when y does equal 0 in that first line. Oh, there's probably some XOR way to convert it to Holonomi, but the specific task here is to convert it to an implication. But yeah, I think the fourth line does deal with y equals 0, in the same way the first line deals with y equals 0. Nothing that interesting happens. So like, I don't think that first line is really dealing with y equals 0 in that interesting of a way either. And the same with the fourth line, it's not really dealing with y equals 0. What kind of maths do you like doing? So I have a bachelor's in applied math. My favorite thing is probably differential equations and like modeling. You know, clearly I enjoy modeling. So yeah, I'm not sure what else to say on this one, Ben, but you're gonna hop off to bed? Okay, sounds good. 6 hours at uni tomorrow to find an answer. All right, no worries. Sleep well, man. Okay, I have too many tabs open. All right, let's erase the whiteboard. Oh gosh, Sahil over in the YouTube chat. Are you still here? I'm sorry, this problem ended up. I thought it'd be a lot quicker. Okay. If that person asked a question earlier left, then I'll just go back to doing some studying stuff. Okay, I'm not seeing anything from that person. So back to doing Penn Center's complex variables. Can't be operating a research paper of category theory? No. I would be worse than useless there. So yeah, this is something that I've been doing in downtime, at least for today's stream. It ended a couple weeks ago, but Penn Center, another streamer, was teaching an actual complex variables class on Twitch. And he put out this like final exam here that I'm just kind of doing for fun and to fill in the downtime between questions. So I had just done part A here. And I need to go to part B now. And I need to remember what the Cauchy-Riemann equations are. You need to revise your complex. Oh, okay. Oh yeah. Ugh. I need to look at the actual notes for this to see the Cauchy-Riemann equations. Sure, they're not far away. Aha! You can't hide forever. Wow, this was not great resolution. U sub x equals v sub y. U sub y equals negative v sub x. Ah! Don't go up there. z is z conjugate. Also say f of xy is equal to x minus iy. We're going to need that form for Cauchy-Riemann. So u sub x is 1. V sub y is negative I. And the issue, we don't have to check the other part of the Cauchy-Riemann equations, which is 1 is never equal to negative I. So there is no value of x and y such that those two things are equal, so this function is nowhere differentiable. I think that's all you really need to do there for part B. I don't know why I explained the entire thing. I just need to do question 2 here. Determine where f is differentiable. Determine where f is analytic. Okay, so this is where... Okay, I remember looking at this one and I got a little bit weirded out because a function being analytic means that it is differentiable. So I'm not sure if you're supposed to get two different answers for part A and, or for, I guess, part 1 and 2. Why does Penn Center go from A and B to 1 and 2? I feel disturbed. But, determine where f is differentiable, determine where f is analytic. I wonder if there is a distinction here that I'm not picking up on. Integers page are fun because they essentially just mean the Jacobian is a complex number transformation. Oh yeah, wait, I described that somewhere as like being like an amplitwist. Hey Lucas, wish you could actually do some stuff here, but it's all in Dutch, so it's kind of hard unless you can speak Dutch. Oh, I cannot speak Dutch. I've used translators before, and I've been able to get by reading like the Google Translate thing. It even works for images too, and looking at the actual like math. Yeah, I'm just debating between the difference between here and here. It seems like it should be the same answer. Math, yeah. So if you want to try posting something, Lucas, I'll take a look. But yeah, if I can't understand it, then it might just be out of luck. It's up to you. Oh, okay. I guess in the future then. I'm open to trying to deal with translating it if someone has a need. So sounds good. There's also, I think there's at least one Dutch speaker who comes around the stream sometimes. So if they happen to be around too, they might be able to help out. Differential at a point, but not at an open. Oh, for an open set D. Well, do I know? All right, sounds good. Thanks for popping in. Right, I think maybe something like that came up during the class, but I don't quite understand what it means to be differentiable at a single point. That seems to violate kind of like the limit definition of a complex number, or of a derivative. Like you need to be able to go a delta z out. But I think that might be the subtlety. I don't remember how to interpret that. Y cubed plus 3x squared y minus 3y plus I x cubed plus 3xy squared. Wait. Minus 3x. All right, so u sub x is 6xy. V sub y is 6xy. So u sub x equals v sub y for all xy. Now u sub y is 3y squared plus 3x minus 3. V sub x is 3x squared plus 3y squared minus 3. E. Did I make an oopsie? I'm copying the problem down. I know, Pinox, I was getting the same exact vibe. Like that function looks kind of factorable, right? Because your equation are satisfied near a point. Derivative in a multivariable sense that derivative isn't a valid complex derivative. Interesting. Oh. Do we get a quadratic? No, we get a negative sign. Huh. On the right side. I was hoping the y squareds would cancel in that we can find like 2 points where for x, and I assume that'll be where the distinction comes up. But this is going to be something, this is going to be a slightly different beast. So we're going to get 6y squared on one side. Negative 3x squared minus 3x. That's positive 3. We add another 3 to it to get 6. Oh, it's a circle. Oh. It's a negative. Okay, let's bring these two terms over here, I guess. Yeah. That's kind of cool. And the number 17 should show up somewhere in this final, because I know that Penn Center always inserts 17. How do we complete the square here? The 1/2 is a problem. Oh, is it going to be an ellipse? It has to be an ellipse. I'm going to multiply everything through by 2. No. I think for an ellipse, we want the denominator. So let's factor the 1/2 out. X squared plus x. How do we complete the square with that? Minus b over 2a. It's going to be a quarter? And then that's 2 plus an eighth. 17! Dang it, pen center! That's the 17. I'm glad I thought about that. Okay, x plus a half squared over 2 plus y squared equals 17 over 18. Oh wait, 17 over 8. I think you want an ellipse to be equal to 1 though? Usually, so we can multiply each side through by 8 over 17. I think like that is how you write the ellipse in standard form. I think so, Holonomi. And you gave an example, f of z equals the magnitude of z squared is only differentiable, complex differentiable at the origin. Oh. 102 minutes out of 180 minutes, not bad. Oh, did you actually finish or did you just have to turn something in before the time ran out? Hey, Thunder. You actually finished? Nice job, Joseph. Do I think that this is nice for making you not feel as dumb as research does? That's gotta be crazy. Are you doing research on category theory then? Flag some questions though, because there shouldn't be an answer to them, but it was recorded that there are. So I put the answers I think they're asking. They were marked correct even when they should be incorrect. Oh, yeah, that's weird. I was able to figure out what the answer is supposed to be. Are you a student, Holonomi, or are you like a... or do you like already have a PhD, or like... Just out of curiosity, you don't have to say anything about you that you don't want to say. You heard of that new game Core Keeper on Steam? Is it new? I remember seeing it a while ago. I don't. Maybe it only recently came out fully. Core Keeper. Oh, it came out fully recently. Even if I haven't started PhD. Oh, okay. That's still like exciting though. I had it on my wish list for the longest time. I took it off my wish list for some reason. I apparently lost interest in it. It could be a game that I like though. Should play it. I'll add it to my wish list again, and probably unwish list it in like a year or something. But you love watching it. It could be cool. It'd be something I want to like be wrestle some friends into or something. But I'm hopefully tomorrow I want to start up a Stardew Valley run. And I think I found this game looking for games similar to Stardew Valley. Same was for a year. You actually got it last week. I haven't played though. Oh, nice. Oh, and thank you for the follow. Oh, it is on sale like right now. I guess for coming out. The reviews are very positive. It's good to see. 16 bucks. If I do play, it probably won't be anytime that soon, but I'm not uninterested in it though. It's got 50k concurrent players right now on Steam. Oh wow, that's not bad. So I've thrown some numbers around on the whiteboard, but how do we actually answer parts 1 and 2 here? Programmable automation. Ooh. Actually, when is the Factorial DLC coming out? It's in October, I think, right? Because the thing of programmable automation is making me think of Factorial. 21st. Oh, do you play too, Lubird? Oh yeah, Holonomi. Thanks for the work, Thunder. Oh, have you not known about it? You've been missing out. Yeah. It's gonna be so good. They said it's gonna be an entire another Factorial game worth of content. Yeah. Hey, Aditya. Like, I've been waiting for this thing to come out for so long. Yeah. What? Okay. What? It's October 21st. What day of the week is that? A Monday. Maybe when it comes out, I'm gonna stream that thing for as long as I can, for as long as I can stay awake for. Because I'm really hyped for it. So let's get into the first game. I think they said it's gonna be the same price as the base game because it's an entire extra game's worth of content. Oh geez, Dia. It's 3:30 in India. You should get some sleep. Oh, the base game long ago. Yeah, I don't know. They've increased the price a little bit, I think, but it's still relatively cheap. 35 bucks. It's not unfair. It's 8 a.m. in Australia. Oh, geez. Oh, the DLC's on Steam as well. I better wishlist that. Hell yeah. Solving logarithms. Oh, nice. But yeah, no, if you do plan on playing Factorial 10 bucks, my unsolicited advice is don't be ashamed to look up how to play Factorial, like how to actually organize your base in a proper way, because when I first played it, I tried to do it blind, and my base just became way too much of an organized mess, and I gave up on it for a long time until I just looked at a YouTuber and how they organized their base. And then I really fell in love with the game once I actually learned like how to play it. Learning how to run the spaghetti is fun too. Yeah, that's fair, but at least I couldn't actually make the spaghetti work, and like I just got to a point where it was too hard to make progress. Yeah, so I watched two different YouTubers. One of them kind of did organized spaghetti, and one of them did very rigid like city blocks. And so I kind of do a style that's somewhere between them. More toward like I still do the city blocks, but I don't mind spilling a little bit over in the city blocks and stuff. Like just the idea of having a main bus is the most important thing, I think. Oh, thanks for the kind words, Aditya. Kevin, about the same thing? Did they do a problem that was Legos? Hmm. What's that's week 2 class 2. What's week 3? What's week 3 class 1? Because I think I'm gonna mess something up here. Wait, what? Week 3 class 6? Hmm. Still streaming about 2.2 hours. Go to sleep because you got to teach in 8 hours. Oh, yeah. No worries. Good luck with your class. It was good to meet you too. Hope you sleep well. Sorry, I'm just typing in a different thing and I'll get back to the math. So yeah, the thing that I'm worried about here is that I've gotten an ellipse where they're okay, what do the Cauchy-Riemann equations actually say? Maybe that'll be the answer to my question. Because I'm trying to figure out how I'm actually answering parts 1 and 2 based off the ellipse that I found. Like, what do the Cauchy-Riemann equations actually say about a function that meets the requirements? Assume f is differentiable. Okay, so I think f is differentiable on the ellipse that I found. I think f is analytic nowhere. Because what open set D can we name that would, like, for that ellipse? I don't think we can name one because the ellipse is just like a line. We would need like an interval or a disk or something. Well, I guess a disk and interval. We would need like a disk. But I guess if we had an inequality where like it was the ellipse filled in, but not the border of the ellipse, then we'd be talking. But we have the exact border of the ellipse and nothing else. So there is no open set D where it's differentiable, I think. So I think that's the catch for why we get different answers between part 1 and part 2. Now, the Mobius stuff, I don't think I paid as much attention as I should have. I think I remember seeing the introduction of the Mobius transform, but I don't remember learning what it was actually doing. All right, so I guess let's just look through the notes a bit. Homogeneous coordinates. Z1 over Z2 when Z2 is not 0. So Z maps to Z1, infinity maps to 1, 0. Z1 over Z2 maps to Z1, Z2. Z1, 0 maps to infinity. General linear transformation between two homogeneous sets of coordinates can be expressed in this form. Just go into the non-linear mapping this in the complex plane. Ah, so this is the fact that we need here. So we'd have 1, 1, 2, 3 for our matrix. So we can get the matrix and get the eigenvalues and eigenvectors. The fixed points are going to be anything on the eigenvector, I believe. I hope. Okay, so the matrix M is 1, 1, 2, 3. Right? Right. So if we get our eigenvalues, these are bars now. Okay. Oh, are we getting... Is this irrational or complex? I feel like these are going to be complex. No, they're just irrational. It's gonna make finding the eigenvectors annoying. be a minus there. Swap the 2 rows. It's always better to get the rational one on top. Take this one, multiply it through by what do you want to multiply it through by? I guess this is weird. I want to multiply it by a half, and then we want to multiply it by well, God, it shouldn't be this hard. Sorry, we don't multiply rows, we add rows. Or we can multiply by a scalar. So we could add 1/2 times 1 plus root 3 times row 1. And that'll give us the 0 down there. Then afterwards, we're going to multiply row 1 by a half. Ideally, this becomes 0, because 1/2 becomes 1, and then we get 1 plus root 3. Plus root 3. I should put this into Wolfram Alpha. I'm losing confidence. Wait, how do we get rid of the radical there now? Does 1 plus root 3 times 1 minus root 3 end up in a radical? 1 minus 9? No, 1 minus 3. I guess we do that. We can take... Before we do that, we can get rid of the root 3 up in the top row, though. God, okay. Wait, don't I want that to be a 0? Am I just getting the identity? This feels weird. I feel like I'm doing something wrong. These numbers just feel weird. Can we verify my at least the... I can now use in Wolfram. No, we do get that. Yeah, I'm definitely doing the eigenvectors wrong. Why am apparently I'm able, like, why do I think I'm able to get rid of the radicals when I feel like I know that I can't? It must be what I'm doing with that. No, that does get rid of it. We're allowed to multiply a row by a scalar. Let me check the eigenvectors again. Okay, no, there is a radical. I wouldn't put it past myself to plugged in lambda equals 2 plus root 3 wrong. 1 minus parentheses 2 plus root 3. No. I'm still doing something wrong, so I'm getting I'm getting a single solution when I should be getting infinite. Many. Oi. What am I saying? I'm expecting the bottom row to be 0. Hey, Neolithic. Yeah, what's the question? Apparently I just can't do row reduction anymore. Oops. Oh, sorry for the shaking. It's an earthquake. I don't know why I'm doing this. Like, I should know what I'm going to get, but... Oh, Wolfram doesn't even do it unless I tell it to. Yeah. That's not what I want. Ugh. Oh, wait, there. I don't know. Did I incorrectly evaluate? Oh, I think I see my mistake. Anyway, look at you know, like it's saying, is a triangle ABC where DE is parallel to BC. You have to prove DB over AB is EC over AC. It's 42. Oh, thank you, Hardlocked. All right, Neil, let me try and draw what I think is happening. Wait, what's parallel to what again? ABC, DE is parallel to BC. So you have something that's kind of like this. So BC is parallel to DE. And we want to show DB over AB DB over AB is equal to EC over AC. No. Oh, they're swapped? Like that. Wait, I did the same thing. Sorry. Not like that. I didn't actually swap them. A, B, C is the big triangle. D, E is the small triangle. There we go. No? My cannon's blocking it. I'm just Googling it. Oh, this is perfect? Okay. And you know what? The more I actually look at it, I don't know exactly how to do this offhand, but I found the exact same triangle on Google, and the exact same thing on Google. So let me, Thales. Okay, yeah, AD over DB, AE over EC. Hey, Clunk. That's a nice emo, wow. Thanks for being here. So I'm just gonna read through this proof with you, I think, because I don't know how to do this offhand, but the angle ABC is equal to angle ADE because it's a parallel transversal. ACB is equal to AED by the same logic. Then by angle-angle axiom of similarity, we can conclude that these two triangles are similar. Okay. We know that the corresponding sides of a similar triangle are proportional, right? So AB over AD is equal to AC over AE. Oh. Okay, this isn't, now that the idea has been given to me, I can see what we need to do here. I probably wouldn't have figured this out on my own, at least not quickly, but I'll drop the link in chat too, but I'll actually go and explain it here. Okay, so the first thing the website points out is that this angle and this angle are the same. And that's because anytime you have two parallel lines and then a third line going across them, you know that this angle equals that angle. So it's called a parallel transversal, I think, and the exact same thing is happening here. And by the exact same logic, we can say this angle is the same as that angle. Oh yeah, Kwong, there's a lot going on the whiteboard. Can you explain the question? You know the concept. Oh wait, and then you said, okay. So is this the, like, are you asking to explain, like, should I keep on going with this explanation for the proof, or is your question something else? And until I see you say something else, I'm just going to keep on explaining the actual proof. But I'll try to check in on chat periodically, and if you please, like, do stop me if your question is actually on something else. So yeah, we've shown these swingers are the same, these swingers are the same. So since AED equals ACB and ADE equals ABC, we know that the small triangle ADE is similar to the big triangle ABC. Actually, I can afford to lose this work here. Okay. So, check chat. Both proof as well as explanation. Okay, well, before I proceed further, the thing that we want to show is that this line segment DB in this, oh wait. Let me just draw it separately here. Isn't this actually, wait. Let me look again at what you wrote. DB over AB. EC over AC. So actually, I think the actual proof that we're doing is a little bit shorter. So what the question is asking is, if you have any triangle like this and you cut it with a parallel line to one of the sides, the ratio of this bottom part to the entire segment is the same as the ratio of this part to the entire segment. So if this line cuts this like side into like 50%, like just in half, it should also have cut this left side in half as well. Same thing if it's like 2/3 or 1/3 or whatever like proportion you want. It should have cut off an equal percent of each part, of each side, is what this is saying. Yeah, Luber, that's why I said like, oh, we can afford to lose that, because it was this part where I made the mistake, or like in the next line. And so what we've done so far is find that this small triangle is similar to the bigger triangle, because all their angles are the same. And now I think this statement follows directly from the similarity. I think we can just go straight to the conclusion here, because these are corresponding sides. Oh wait. No. Sorry. We can't quite. I see. So what we have here, two similar triangles, ADE, ABC. ADE. ABC. So we know that AD over AB, let's write that, is equal to, so AD over AB is equal to AE over AC, because that's what it means to be a similar triangle, that the sides are proportional like that. So we nearly have the thing that we want, but we need to figure out a way to go from AD to DB and from AE to EC. That's the only problem that remains now. Prove it using Thales' theorem? At least from the website, it seems like this is Thales' theorem, so you can't use Thales' theorem to prove Thales' theorem unless I'm misunderstanding you? Unless I'm misreading what Thales' theorem is, but if you know how to prove it yourself, I'm not sure why you're asking me then. Oh, Thales' theorem is a little bit different. So wait, I'm confusing you. Like, do you already know the answer to this question? Okay. I'll leave it then. Yeah, I mean, I guess, so I don't know what you have in your toolbox, what you're allowed to use. If you do have, if you're just allowed to use Thales' theorem, then yeah, we can shorten the proof, but like, I didn't know that you have Thales' theorem to use, so the important part is that you understand the answer to the question. but I'm not gonna. By the way, I have more subscribers than you. That's not hard to do. We were just doing the geometry jed, but it sounds like the person figured out the answer to their own question, so I'm about to go back to the matrix thing. So yeah, the thing I messed up on is that the bottom right. I didn't do that foiling correctly. What's my view on India? I don't really have a view on India. Or I know very little about it. So what's happening here? The radical still goes away here, doesn't it? What am I doing wrong? Oh, I'm adding it. I'm not multiplying it. Oh my god. That's the problem. So that's 1. Wait, no. Why can't I do this math? It's 1 minus root 3 times 1 plus root 3 is negative 2. Oh, and then it's times 1/2 is negative 1. There we go. Okay, that's what I wanted. Okay. Oh my god. Okay, so ugh. Our first eigenvector. Did I make my psi right? I always flip it. I think that's the right orientation. Like that. Let's see if full frame agrees. Ah. 1/2 minus 1/2 plus root 3, or... Okay, I flipped the sign, but that's fine for an eigenvector. it's flipped consistently. Does Wolfram Outfit tell me which one it's associated with? No. Oh, yes, it does. Okay, yeah, I'm fine. And I'm just gonna cheat for the second eigenvector because I don't feel like doing that work again. I mean, there's actually probably like a pattern. Like, it's probably always the same thing, just with a flip sign. There we go. What are the fixed points of this matrix transformation? Is my camera being weird? I don't know why. I felt like I was getting like slowly out of focus. It's going to be I assume it's going to be any complex number with argument equal to whatever these correspond to in the unit circle. So we're going to get two rays of invariant points. Hey, Eric Fernando asks, determine G prime of f of 1, or is that composition? G is the inverse of f. So, Eric, is that like, is that G of f of 1, or is there a prime in there, like there's a derivative? Hey, Hamza, I'll solve any problem that I know, and the problems that I know are like calculus differential equations, like things you'd find in a first year, like undergraduate university. Like class and below. Yeah, if it's a basic problem, that's even better. Find all solutions to x cubed equals 7 cubed. Am I reading that right? I can copy it onto the board. Like this, all solutions of x for x to the 3 equals 7 to the power of 3. I think it's just 7. But tell me if I'm interpreting the problem right, and then I can try to explain it more. Oh, imaginary roots. Hey, Suna. I am well. Hope you are too. All right. I think there's two ways you could go about this. The way that comes to mind for me is start by saying 7 cubed is 343, subtract it over, equals 0. Personally, by inspection, we know that x equals 7 is a root here, so I would just do polynomial long division and divide out the x minus 7 root. I think there's a complex numbers way where you let x equals re to the I theta. But this is the way that comes to mind. This way that I'm personally more comfortable with, at least. So we start by doing an x to make the x cubed match. Oh wait, sorry, an x squared. So x squared times x is x cubed. X squared times minus 7x is minus 7x squared. Subtract these. Those cancel. This becomes a positive 7x squared. Drop down the next term. Now take the 7x squared. We make the x match the 7x squared, so we're going to do plus 7x. So 7x squared minus 49x. Subtract them. You get 49x minus 343. Now we need to make x match 49x, so we're going to do plus 49. Really? Oh. Yeah, okay. So we get we don't expect there to be a remainder. Subtract 0. Okay. So we know that this thing, oh gosh, I'm gonna room, is equal to x minus 7 times what we got there. X squared plus 7x plus 49 equals 0. Now that's a quadratic, and we do the quadratic formula to get the imaginary. Suna, it's not just 7 because it's also imaginary solutions for x. So I thought the same thing at first, but then this person said that they're doing imaginary numbers as well, so. We can use our knowledge that 7 is one of the solutions to find the others, though. So that's what I did here with, if we know that x equals 7 works, let's divide out x minus 7, and then we get now as a quadratic with imaginary roots. So we can also do quadratic formula. I'm just going to erase this. So that's b, plus or minus root b squared minus 4ac. 4 times 49 is 200 minus 4 is 196. Right? Seems right enough to me. Over 2, 49 minus 196 is 147. That's a terrible number. I hate that number. 147? Let me check that. It is 147. Terrible number. Is it prime? It's not. It's 49 times 3. Negative 147 over 2. Okay. 147 is 7 squared times 3, so we can pull out the 7 squared and square root it on the way out. So we get, and the negative sign can become an I, so we get 7i root 3 over 2. So all of our solutions are x equals 7, negative 7 plus 7i root 3 over 2, and negative 7 minus 7i root 3 over 2. Let me know if that's right. Why? So do you know how to do polynomial long division, Hamza? And Eric Fernando, if you can clarify your question, I'm happy to work through yours too. I just didn't understand if that was g prime of f of 1, I guess, if you're still here. You got it? Okay, great. You have other problems? Okay. In the meantime, Wolfram gives the Roman numeral representation of 147. It's kind of funny. Hey, CDT, feel free to post it. Well, welcome in. What is F? I don't remember seeing F. The common Roman soldier saying, well, LXIX written on it. And he just says nice. Oh, it's 69. No, that sounds hilarious though. How did they 69 before our number system was invented? These are the questions that we need answers to. m be the smallest integer such that m squared plus m plus 1 squared plus m plus 2 squared is the square of a positive integer n. How about over to the Twitch chat? Take that away because I'm not looking at that. Oh. Could this be the sum of squares formula? Sum of squares formula. This mechanics class is full of women. That's unexpected. Okay, so I'm thinking about... Oh, where'd it go? It's not a bad thing, though. Yeah, this is the type of formula that I want, I think. At Wellesley? I don't know what that is, but either way. How would we use this formula in Hamza's context? So we don't have from 1 through m plus 10. We have from m through m plus 10. It's a private women's LAC and MA. Oh, okay. Well, go forth and slay. Okay. I think I have like half an idea. I have an idea to get started on this problem. I don't know if it's going to actually help. Set problem. Okay. So we basically have this equality here. And we want to manipulate it to find, basically we want to hope that we get an n plus n somewhere here. So my only real idea to try for this problem is to work with this. So we know that 1 squared plus 2 squared plus 3 squared plus dot 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 plus all the way up to m plus 10 squared is equal to m plus 10 times m plus 11 times 2m plus 21 over 6. Hey, Likith? Praying for JE? Oh, good luck. It's not an easy exam. I'm not usually too good with solving them. That one I could take a look at some point, but I have to do this problem, then at least one more before I can get to you. So let me write out the general formula that I just used. If you have the sum of squares up to some number n, that's equal to n plus 1, 2n plus 1 over 6. Just make sure I got it right. Yeah. So all I did is instead I took the sum to be n plus 10 as the endpoint, so anywhere there's an end here, I put n plus 10. But the issue is we don't have this, we only have m through n plus 10. So what we need to do is also consider the sum of squares. And this might end up not even being the right approach, and I'm going to say, sorry, but I don't know the answer. But this is the only thing I can think that the answer would be. We can also consider the sum of squares up to n minus 1 squared, which would be right before m squared. And we could subtract off this part of the series from here to get only that component. And hopefully something good happens. So I'm going to use the same formula with m minus 1 times m times 2m minus 1 over 6. So now this minus this is this. So that also means this minus this is this. So I'm going to take the left-hand side of the equation and make it this thing minus this thing. And I hope it simplifies in a nice way. Let me bring the m out front. Okay, well, immediately, we can't really simplify this without multiplying everything out, which is kind of terrible. Oh shoot, and the problem text is covering up the identity that I wrote. I'm going to quickly use Wolfram to see if if my idea will even go anywhere. Because I don't want to multiply this all out just to realize it's not going to work. It's not going to work. I was hoping if you expanded it out, you would get something cleaner than this. Get some more cancellations. Why don't the cubes cancel? The cubes should cancel. Should they? Oh, I did a plus there. That's why. It's a minus. That seems better. I don't know what to do with that, though. It doesn't help us get to m plus n, I don't think. Yeah, I'm sorry. I don't know what else to try with this problem if that doesn't work. And I don't think my idea works. That I can figure out. Oh, that's amazing, Joseph. Wow. I think I've seen a problem like this before. I don't remember how you do it though. Not like this. Yeah, I'm sorry, Hamza. I don't think I can figure out this question. I can Google it, I guess. Do you already know the answer to the problem? Because I did do this on the square. Or like, do you already know the answer to the problem, Hamza? Oh, okay. Oh, just a formula I never heard of? It's probably a rearrangement of the formula that I used. I don't exactly see it, but... Wow, that's a mean... They make you figure out that something is 77 squared? Yeah, I guess that's the answer here, Hamza. Whatever this formula is, I just haven't seen it before, to be honest, so... Like... I don't think I would have been able to... Or I think you just kind of need to know this formula to figure out the problem. Yeah, so I'll leave it on turn. You can take a screenshot of it or something, but I'm going to start looking at... was there someone before Likith? Actually, I don't see anything else need to chat before Likith, but... Yeah, look, if you're still here, I read your question. I don't know if I know how to do that one either. It seems like I can maybe figure out with a lot of time, but I don't really know how to approach that offhand, and I'm probably gonna want to wrap things up soon. I have a Discord where we can post things, but I don't think I'm gonna be streaming for a lot longer. I just know there's someone who posted something in the Discord before this. Oh gosh, I don't know if I can do this one either though, at least right now. Yeah, look at that. I was just saying that I'm not sure that I know how to do your problem. And I don't think I know how to do this problem on screen either. I'm getting kind of tired. Sorry about that, but yeah. This one is just, the one on screen right now is just terrible. Um, yeah, guys, I'm just gonna wrap things up. These questions, the earth which people have asked, but they're just way too hard for the amount of brain power that I have right now, and I'm getting tired. So, let's just wrap things up. Looks like OB is streaming. Yeah, Hamza, I know one's gonna be binomial, but it's just gonna be a lot of algebra there, and I don't have the brain power to do it right now. So I'm gonna cut the YouTube stream off here. So if you're on YouTube, thanks for being here. Back on YouTube on Thursday, probably. And yep, I'll see you around.